How do you know? So on your machine, there should be a message that FPS completed successfully. Yeah? It is there? Okay. So that means, and see the time, it should say 60 seconds. I'm sorry? No. So, FPS, when you start running the simulation, it will immediately create the assembly file. Okay? But that doesn't mean your simulation is complete. The simulation is complete when you get the message that FPS has completed successfully. Okay? And you see the real time, 60 seconds, on your command prompt. Alright? Cool. Alright, so now you have the simulation complete. So how do you see the results? So the visualization tool for the FPS is the smoke view. Okay? So there are two ways you can run the smoke view. You can use the command prompt, or you can open it by going through the program files. Okay? So if people want to do command prompt, use command prompt, open your command prompt. Yeah? Then navigate to your folder. So CD, desktop, CD folder. Yeah? Or in your command prompt, maybe you are using the same folder already where the FPS has completed successfully. Okay? So now you can run the command called smoke view space and go to your folder. In your folder, you should have a file something.smb or job1.smb. Yeah, it's there. Okay, so smoke view space job1.smb. You did it? Okay. Press enter. So if you press enter, okay, so you can have like a 3D view or something. Alright? So how do you use the smoke view? And there is one more way to run the smoke view by going to the program files. Okay? So if you go to your folder and right click in Windows, then you can say open with, and then open with, right? Then choose another program. No. Are we on the same page?
Yes.
Yes? No? Okay. Then file models, SMB6, and then there is smoke view application file. So, and then you can say just unread. And then every time the SMB file will open with the smoke view. Okay? Alright, so smoke view space. Smoke view. VIE. Yeah? Yes, I'm going to do that. Yeah.
How to do
so you navigate to that folder and then write smoke view job1.smb. Alright? Cool. Now, smoke view is basically a tool using which you can see the results. Alright? So, So to see the results, you click on right click on the simulation. Okay? And here you can choose basically what you want to see. If you want to see 3D smoke and just the temperature, let's say if you want to see the fire, you select the temperature, and now you want to see the fire. Okay? If you want to see the temperature distribution on the slice, then you go to slice, select the temperature, and then you select that slice. Y is equal to 2.0. Okay? Right? Yeah. So, do you remember the code? So just take a minute and look at the code and make sure you understand each and every line from the code. Okay? So in this code, you have one file called pby is equal to 2. Right? So basically you told FDS to generate the temperature distribution at y is equal to 2. Okay? So when you go to the smoke view, in the temperature, it is giving you an option for y is equal to 2. Okay? Now let's say if you want to create more slices, then you basically add those in this code. Okay? So let's say if you want to have a slice at x is equal to 2, what will you do? So you will write basically ampersand LSTS PDX is equal to 2, yeah, comma, quantity is equal to temperature. Yeah, same thing. Are you with me? Any questions? Okay. Now, what else you can do with smoke view? So now this simulation maybe is too fast, right, to view. Okay. So if you want to slow down the frame rate, again, you right click, go to show or options, go to maximum frame rate, and then you can select what is the frame rate that you want. So let's say you select, I don't know, 4 FPS, then you can see the results maybe at smaller intervals. Yeah? Are you with me? Any questions? Right click, then options, then frame rate, maximum frame rate, and then you can select 4 FPS, 8 FPS, whatever you want. Yeah? Okay. Now, there are like hundreds of options here, and I don't know whether we should spend time in going through each and every option. But let's say now, if you want to now capture all these images, okay, and generate maybe a video, okay, for your conference publication or whatever, then you go to options, you go to render, yeah, and under the render you will have number of options again, like do you want to save the, so it is going to generate a number of frames, okay. So if you remember in the code we said we gave a command ampersand and down is equal to 60, right? So basically we told FDS that create the files at every second, right? Because your simulation time was 60 seconds, right? So it is going to generate maybe around 60 PNG files, okay? Alright, so how do you want to save the files? Using time or a frame number? Do you want PNG, JPEG, whatever, right? At what rate or something, from all frames, every second frame, whatever, right? You can even choose the resolution. The easiest way is if you click on settings, So if you see, if you click on render settings, you will see this kind of window. Okay, and then if you click on start rendering, inside your folder you will have number of images created. Yeah, and then you can use these images and then I don't know, use whatever Windows software or Adobe Premiere Pro, whatever, to make the videos. Okay, there is a Google tool in SmokeView where you can actually create a video, but it is actually more work than doing this. Okay, here you have actually more control than what SmokeView generates. Cool? Are you with me? The next thing is now, this is just visualization, but for publication purposes, you may want to plot the charts, right? So inside your folder, you will have a bunch of CSV files. Yeah? How many CSV files are there? 4. Right? So again, if you look at your code, we told FDS that we created a sensor called device ID is equal to TAR1 at this location, and because we wanted to measure the temperature at that location. Are you with me? Is there a question? Alright. So now we want to see what is the temperature readings, right? All those temperature readings are actually saved in the CSV file. So there is a CSV file which will have an extension _DEBC, which is devices, which is your command. Yeah? Okay, so open that CSV file. CSV file will open in Excel. Did it open? Okay, so that is your data file. Okay, and you want to room your data. So save it as Excel file, and don't play with the original file. So did you open the Excel file? Okay, save it as, so this is a CSV file. Save it as an Excel file. You should save it in the same folder. Yeah, I mean, whatever you want to name, that's fine. That doesn't make a difference. Yeah? Yeah. I'm sorry? Inside your the folder that you created for simulation. Where is the folder? Yeah, so job 1 underscore DEBC. Yeah. So how many data points do you have? Where is it? So you should have at least 60 data points. Yeah? Everybody's on the same page? Yeah? Okay. Alright. So then, the first column is basically a timestamp. Make sure you save it as an Excel file. Okay, don't take the CSV file. Alright, so the first column is the timestamp, second column is the temperature value. Okay? So if you want to plot it, what you should do is yeah, you can make graph. So now this is the original file, and if you see the format, you will see this thing, right? The quotation, the single quotation mark at each and every cell, right? So you may not be able to, convert that into numbers to plot the chart. Okay. So go to data. And click on text columns. And then go through the steps, and it will basically convert it into a number format. And then select the column, go to data, then go to in the data there should be a text column option based on whatever Excel version you are using. Okay. And then you will see something like this if you do that for both columns. Select the column. Are you with me? Yes, no? No? Okay. Give it to me. So you select the column, text to column, delimited, then here what your separator is your single quotation, right? So then you do that, next, finish, and now convert this format cell into a number. Yeah, you can do that. You can do the same thing for time. Do you want help or you're okay? Okay. You okay? Cool. Yes. Okay, so can you help other people?
अपने दोस्तों को उठके जा रहे हैं क्या यार
So people who did it, please help others. Yeah.
What was the next step?
You guys did it? The same thing for time. You did it? We are firefighters. Are you guys okay? Alright. So if you have both the columns, then you should know what the chart. So plot that chart as well. If you know Excel, you know how to plot the chart. You know how to plot the chart? Select the column. do this for whatever records you have. Okay? Are you with me? Questions? There are four other files, right? There is underscore CPU file, which basically is recording your computation resources. You don't need that, typically. Okay? Then there is a steps file, which is also recording, keeping a log of the simulation. You typically don't need that as well. And the HRR file, by default, FDS takes the heat release rate for the entire simulation. So if you want to plot the HRR, you can use that one. But typically, the underscore devices file is the most important file. Okay? Are you with me? Alright. So now, x1, x2, y1, y2, z1, z2. Yeah? And so that is your main. Are you with me? Then you need to define basically what type of surface it is. Okay? So you are going to define that basically surf ID is equal to open. So FDS will know that it's an open boundary condition. Okay? So start typing. So it should look like this. Are you with? Yes, no? So you have the bent ID line on your previous job file, right? Copy that, or you are modifying the existing file anyways, and it should look like that. In that line, you also see IOR. IOR stands for index of orientation. And that is a very important concept, because if it's an open boundary, right, FDS needs to know which way it's open. Is it open towards the positive x-axis or a negative x-axis, right? So all the combustion products are going to flow out of the domain in negative x direction. In this direction, right? So your IOR is going to be -1. Are you with me? Everybody understands why IOR is -1? Okay? No? Okay. So let's imagine this is a room, right? The combustion products are going to be formed, right? And they're going to flow into the atmosphere, right? Okay. So this is your x mean plane. Okay? FDS needs to know which way the products are going to go into the atmosphere. So this is your negative x-axis, right? So we are basically saying that the IOR is equal to -1. That means the open boundary condition is towards the negative x-axis. Yes? Are you with me? Okay. Yes. Yes. Are you with me? Okay, so complete your first line. Did we do it? Alright. The next line is for the x max plane. So copy the x mean line, modify the coordinates. What should be the IOR for the x max? +1, right? So all the products are going to move out of the computational domain into the atmosphere in positive x-axis. Yeah? Questions? Are we okay? Yeah? understands what's happening? Now similarly, we need to specify your domain in y direction. So what is your y min and y max? Yeah? So define your y min and y max. Plane. What should be the coordinates? What will be the coordinates for the y min? Anyone? What will be the coordinates for y min? Plane. So your y should be 0, 0, right? Yeah? Then x1 and x2 will be -1, 5. z1 and z2 will be 0.0 and 0.2, right? Y max is going to be, y will be 5, constant. Yeah? y1 and y2 will be 5. Then x1, x2, 5, z1, z2. Yeah? Are you with me? And then do the exact same thing. Self ID is equal to open. IOR should be -2. Okay? Because you need to tell the FDS that the combustion products are going to go into the negative y direction. Yeah? This is x, this is y, and this is z. Okay?
And 2 is for y.
And 2 is for the y. Okay? 1 is for x, 2 is for y. Similarly, for y max, it will be +2. Yeah? So the products are going to go in the positive y direction. Are you with me? Now what will be for the z direction? What will be the coordinates for the z plane? Or z boundary? We are defining the top boundary, right? So your z coordinates will be constant. 3.2, 3.2, right? And then x1, x2, y1, y2. Yeah? Okay. So let's write those 4, 5 lines. Yes, purposefully I did. It's not a mistake. No? What happened? What is the question? So at least start typing the lines. While you are typing, think about the coordinates, how you got the coordinates. Yeah? Any questions from anyone? Are you understanding what's happening at least? Okay, alright. Why? So for z, the IOR value is 3, plus and minus 3. Yeah? So x is 1, y is 2, z is 3. So z should be positive 3. Yeah? Why there is no z mean? Anyone can anyone answer the question? It's a ground. Right? So the products are not going to go into the ground. Are you with me? Okay. Now
मैं आपको
we will
नंबर
start
देता
building the
हूँ
wall.
आपका इसी नंबर है ना
Okay? So how do you build the walls?
मैं
So
आपको
let's start with this wall. Okay? The left wall. Okay? Alright. So for the left wall, So, if you want to build this wall, what should be the coordinates? Anyone? Let's assume, I don't know, 0.1. Okay? Let's assume 0.1 is the thickness. Okay? Alright, what will be the starting point? What will be the coordinates? So when you build a wall, right, you need this point and which point? This point. Right? So 0, 0, 0 and this point. Right? So if you are assuming that the thickness is 0.1, so your x1 will be 0. What will be x2? 0.1. Right? Okay. Your y1 is 0. What will be your y2?
नाम अगर नीचे जो होस्ट करके नाम
What will be y2? 5. Same as 4. Right?
आपका इसी नंबर
Your z1 is 0. What will be your z2? Key point is your the top boundary. You know what you are seeing to hit the boundary. Right? Your height of the apartment
दुकान वाले
is
नंबर पे
right? I repeat. So, create your first wall.
आप
I just gave you the coordinates.
चलाएं तो फिर मैं जाता हूँ तो मैं आपको दे दूँगा ठीक है हेलो
Point
घर जाओ तो
1,
मैं आपको दे दूँगा
comma 4, comma 3. So you need to create a volume, an object going from 0, 0, 0 to 0.1, comma 4, comma 3. Alright, let's start typing. So how do you create the object? Using the ops command. Ops. Now if you want to name the wall so that you know, okay, when you look at that line in future, that line is called the left wall. So you can name that line is equal to maybe left wall. Okay? Then the coordinates 0, 0, 0.1, 0, 0.4, 0, comma 3. Yeah? x1, y1, z1, x2, y2, z2. Yeah? And surf ID is equal to what? Because let's say if you want to define some properties to the wall, like it is made up of gypsum plaster or whatever, that surf ID value parameter will be useful. Okay? If you don't define surf ID is equal to wall, then FDS is just going to assume that it's a standard inert wall. Okay? You must have received a second email now. Did you get the second email? No? Okay. Copy paste all those lines into your file. Delete what you have. So copy all those lines and paste it in your file. delete everything that you had in your file. Everything. Because I don't want to try to figure out what is the Did you do that? No. Delete everything you have. I don't want to figure out where it is. Where is your Gina? I sent another code. Yeah. Okay, so if you copy pasted that code, now run the job. Run that LTS simulation. Are you able to run the simulation? It's running? Okay. Now run the smoke view file. Run the smoke view file. What do you see? Who is struggling? Come on. Raise your hands. Do you know what's happening? Oh, you have a different problem. Are you guys okay? Are you okay? Are you okay? Help on them. Are you okay? Do you have the code?
FPS.
Are you okay? Okay, which one was running before? Any file was running. Give me the file which was running. Any job file that was running. This was running before. It was running before. That's how you created the assembly file. I'm just going to take it. Paste the code that we just got. Let's try to run that file. So your command will be fds, job to dot text. Yeah? Okay. Are we on the same page? Okay. Are you able to run that code? Did you generate the smoke queue file? So create a smoke queue file. Are you able to run the code? That's fine. You can still open the smoke queue file. So if you open the smoke queue file, it will look like this. Does it look like this? Basically, we just created an apartment. Okay? And this apartment is in has open boundaries. Okay? So now, what do we need to do now? What? Okay. What do we need to do now? Anyone? Now we need to create a door. Right? So to create a door, we have a wall, right? So to create the door, now we need to create a hole in the wall. Right? Okay. So how to create a hole in the wall? For that, this piece of code, ampersand hole, that means it is going to create a hole. Okay. Now ID is basically saying that you are creating this hole for creating a door. Okay. So I am naming that as door hole. Yeah. Then you are creating the door. So what should be the coordinates of the door? So what should be the coordinates of the door? Right? Our door is in this wall. Yeah? So now you can create a door at any position, whatever you want. Okay? My door is at these coordinates. Okay? And then there is a device ID, because later on we are going to open the door at certain instant. Okay? But let's not make that complex right now. Okay? So using this command, I want you to create a door. Look at the command. Okay? Think about the coordinates. So ampersand hole XP. So write a line. Ampersand hole, give a ID, door, write the coordinates, XP is equal to coordinates, and a slash line which is the end of the line. Okay? And I want you to create the door in the geometry you just had. Let's see how many people can create that. Let's see who can do it first. Raise your hand if you created a door. Sorry? You don't have to run the whole thing. You don't have to run the whole thing. You can just open the smoke file without even it's not complete. The thing is, when you are running the smoke view file, just to make sure your geometry is as per your expectation. Don't wait for your simulation to complete until like 60 seconds. You don't need to, because this is not your final simulation. Did you create a hole? Anyone? The command is ampersand hole ID XP 6 coordinates and slash. So your hole is in x direction, right? So it will be 0.0, 0.1, right? It is going to go to the thickness. Yeah? And then, at what position? Let's say you want to create a door in the center. Okay? So if it's in the center, then it will be at, let's say 2. Right? Y1, Y2 is basically the length of the door. Try to imagine what's happening in your head. Okay? You have a door, you have a door box, you want to create a hole in it. Right? So what should be the coordinates? Right? All these things should happen in your head. Let's say the door thickness or the door width is 1 meter. Yeah? And door height is, I don't know, 2 meters. Yeah? And this will create a hole in that wall. And then at the end, you write slash. That's the end of the line. So, how many people created the hole in the door, in the wall? You did? Okay, run that simulation and show me the hole in the smoke view. Sorry? Space is not available. Screen is not showing. Comma, not point.
0, comma 2.
Not 0.2. How to? So people who created a door, now create a window. Create a window. Create a window. Create a window. Sorry? It's in your email as well. Okay?
3.90.
You do it.
4.1.
Alright. So now if you copy pasted those two lines, run the FPS file and then run the smoke view file and check if the door and windows are created properly or not. Are you guys okay?
नहीं हो रहा था ना उसके लिए अभी नीचे जो विंडो का है वो
So run your MTS file, run your smoke view file, and show me the door and the window. Yeah, running. Right. Okay. Are you guys okay? Okay. So you want to create, you want to open the door at, let's say, the 40th second. Okay. So what you do is, in your line for the hole, you add a control logic. The control logic is created by defining a device. So you define the device, it can be any name, okay? So I named it as door open time, so that I remember this device is for opening the door, right? And then on this line, where you define the device, you can type, okay, so now you have to give the same name, door open time, okay? You can place that device like a sensor at certain location, and then what is your parameter to open the door? Your parameter here is, it's a time base. So you are going to say that quantity is equal to time, set point is equal to 40. So it's going to open the door at 40th second, no matter what. Okay? Right now, your door is open at 0th second. Okay? We don't want 0th second. We want 40th second. Okay? Now let's say you want to break the window. So when there is a fire, the window will break because of the heat. Right? When a temperature reaches certain value, the window will break. Right? If that is the logic that you want to implement, then it's the same process. So you create a hole in the same line for the window hole, you add a device, and then for that device you specify the location close to the window, and you are opening the window at a certain temperature. So let's say if the temperature at that location close to the window reaches 200 degrees Celsius, then it is going to open the window. Are you with me? Okay, so I'm going to send you, so you understand the logic? Okay, so I'm going to send you that piece of code now. Yeah. Where are the IIT Bhubaneswar people? The guys. Can you forward an email to them? I'm going to send you the full line, all things, the entire code now. Okay? What you will see is the fire started at around 15 seconds when the temperature reaches 200 degrees Celsius, the window breaks, and then when at 40th second the door opens. Okay? the entire code now. So again, look at this. So the fire started, and around 15 seconds the window broke, and now at 40th second the door opened. Yeah. Now how do you take this? If you also see the smoke, now what will happen is the window broke, so now the smoke is entering the outside as well, and now it is getting out of the computational domain. Yeah? And then with it is also coming out of the door at the 40th second. Are you with me? Okay? I'm sorry? I'm going to send you the code now, the whole code now. Okay? Temperature or any other value, record it at 1 second. Okay? That's what this value is doing. Also record the heat state at every 1 second. Then this block of code is actually defining your, what is it defining? The atmosphere, right? So this is defining your atmosphere. This piece of code is actually from the previous job1.fds, which is, what is this doing? It is the fire, it is the burner, yeah? It is starting the fire, right? So if you compare this lines with the previous code, in the previous code there was no suit, okay? Because in that, you have propane. Propane burns clean. There is no smoke created, right? But for the purpose of the demonstration, I added the smoke so that you see how the smoke is getting out of the windows and the doors and everything. Okay? So if you want to add the smoke, or if you know that your fuel is not clean or it doesn't have oxygen for complete combustion and it is going to generate the smoke, then you can add the soot bag. Okay? Then this piece of code is actually, what is it doing? It is creating the walls, right? It is creating your apartment. Okay? Then what is this piece of code doing? The one below that? What is this piece of code doing? It is creating the events. It is opening the doors and the windows based on certain temperature or a time. Yeah? What are these lines doing? Last three lines? It is recording the temperature at certain location, and this is a slice at y equal to 2, right? And it is also recording a mass fraction and smoke and creating a slice of that. Okay? And now you should have that entire code, copy that in your file and run the simulation, and you will have the exact same thing that I have. Okay? So do you understand the whole code? Delete everything and just copy paste. You have the whole code now.
With this code, the door and the window did not open.
So that was your assignment, right? So find people to do that, right? So if you remember, we are going to create a fire, right? But before you go into the required, you need to create the geometry. You need to have bedroom, you have to have the living room, public hallway, doors and windows. And you know all that today. Okay? So maybe try to create that apartment, okay, using these dimensions. And then if you struggle with it, maybe we can meet, you can work with me tomorrow. Okay? So that's your homework today. Create the apartment. Okay? With your group. So maybe find 4 or 5 people and decide what scenario you want to showcase in the last day. And then run that file as well, the one I sent. Okay? I think we are done for today. Otherwise, if you have any questions, ask me. In the you can add it. So the way you create it is basically you create a file here and then you upload it on the link. That's all, but it's a little bit complex. And I don't know whether people will learn it in the video. That is the whole concept. You should be able to do that. Okay? Alright. So, what are the groups? 1, 2, 3, 4 and 5. What's the scenario? No, I think 5 is so, what is the scenario? What is the scenario? What are you going to simulate in that apartment? What is the event? What are the events that you are going to simulate? That's what I want to know.
Today,
Okay. So tomorrow, I want you to give this kind of event. Okay? You have this presentation, right? So the fire starts. You don't have to worry about the sofa for now. Okay? The fire starts at 0 second, and then which door opens, which window breaks, and stuff that you have to basically present the scenario. Okay? But remember, start building the geometry. Don't wait for the last day. It's going to be a nightmare. Okay? Alright. I'll see you tomorrow.